Welcome to the second step in our journey to understand solid principle. In this section, we will look into open-close principle. Again, in this section, we will look into the definition, examples, symptoms of violating open and close principle, solutions, code example, and in the end, we will do a wrap-up. A good example of open-close principle in real life is the open source library package that you use in your development. As a developer, you install the package and you can easily extend this class without modifying the existing core open source library or logic and write your code around it. So the core logic of the open source is closed for modification, and still as a developer or as a development team, you're able to extend the logic and add new features. So this is a good example of open-close principle. If this example didn't make any sense for you now, nothing to worry. We will dive into details soon. So let's get going. Open and close principle states that classes should be open for extension but closed for modification. That is, we are able to change or extend the behavior of a system or a class without changing any existing code. When you hear it first time, it looks like a contradictory statement. How can something be open for extension but at the same time closed for modification? This principle, if used, will save your most development time in the future. So, the general idea of this principle is great. It guides you to write your code so that you will be able to add extension, new functionality without changing existing code. And that's a boon or quite helpful if you want to extend any code which is already in production live. If this principle implemented prevents situation in which change to one of your class also require you to change all depending classes. This principle is also called as OCP in short. Let's look this in detail with example in next section. Let's try to understand the OCP principle with a scenario example. Say there's a supermarket and its cashier is using a billing software. Currently, the shop accepts two forms of payment, cash and debit card. So the billing software logic has a payment class which does payment processing. Now I'm showing here the billing logic in a very simplistic form for the ease of this discussion. So the billing class has a method payment processing which checks for if the mode of payment is cash or debit card, and based on the mode, appropriate payment processing logic is invoked. So all's well till now. Say the shop is expanding in its business and add one more payment type, credit card. So if you update the existing production code and add one more if statement, then you are violating the open-close principle. Because as per the open-close principle, existing production code class should be closed for modification. If you modify the existing production code and add one more if statement for the credit card, it violates the OCP principle. OCP principle will guide you on how can a new feature be added without impacting the existing business logic. Typically, you do this with the use of interface and you implement the interface. Later in the course, we will be doing a deep dive into the solution and see how to achieve this extension via OCP principle. At this point, just try to get a big picture of OCP. Let's try to understand this principle with one more real-life example. A great example of OCP principle in real life is sitting in your pocket in the form of smartphone. All such phones have app stores, and these app stores let you extend the base functionality of the phone. That is, via the app store, you can extend the phone's capability to allow you to manage your to-do list, play video games, and even serve as a flashlight or wireless access point. OS provider like Google, Apple, they make the core phone functionality closed for modification and they open it for extension. As an app developer, the core OS logic of Android and iOS is not exposed for you to modify. Instead, you have an extension point from which you extend it and add in new features to the phone's capability. Let's look at the cashier example again. We saw how the shop was expanding in its business and it need to add one more payment type, credit card. So if you update the existing production code and add one more if statement, then you are violating the open-close principle. Before looking at the solution on how to apply OCP principle, let's look at the drawback of not following OCP principle. And let's look at the symptoms of open-close principle violation. That is what happens when we don't follow OCP principle. What happens if you go ahead and implement the logic to add new credit card using if and else statement? So the first violation is code stability. We change the existing code so much that they become unstable. As in this case, to support every new payment type, you need to update the existing production code, add a new if and else statement, and this will go on. Say if you have one more new payment option, you need to add one more if and else statement to this code. So as you see, for every new payment option, you will go and update the live production class, and eventually it will reach to a point where we change our method so often that the code will never become stable code. As a software developer, you must have encountered scenarios where when existing production code is modified and redeployed, it sometimes causes the code or application to break somewhere else in a totally unexpected functionality. And since you have modified the existing code and this involved exhaustive cycle of retest, redeploy and re-release, it costs time and money. If you see a lot of switch or if and else statement in your code, it shows the code is rigid and it's not flexible. This statement causes tight coupling across different modules, which makes the application rigid. As a programmer, always look out for the signs in your code. If you see lot of if and else or switch statement in your code, that's not a good design. You are making the application rigid, tightly coupled and hard for future changes. The second pitfall of ignoring OCP principle is that when you have more and more condition to the existing logic, over a period of time, you add more complexity to the code and the code becomes unmanageable over a period of time. For example, as you add more and more if and else statement to this code, it makes the method bulky and unmanageable over a period of time. It's no longer modular and manageable. So those were some of the symptoms of not using open-close principle. Essentially, it boils down to how effectively you can separate the behaviors so that system can be easily extended and never be broken. So how to effectively apply open-close principle? We will see that in next lecture. So as we saw in the previous lecture, if you update the existing production code and add one more if statement for credit card, then you are violating the open-close principle. So the solution will be to let each payment type to process its payment logic. So here I'll be creating an interface payment type. This interface has one method process payment. And each of the payment type, that is cash, debit, card, will implement this interface and will implement the process payment method. So the cash class will have its own payment processing logic and debit class will have its own debit card processing logic as shown. The payment class will be responsible to call the process payment method of appropriate payment type. So if you see here, the payment class is not holding any logic to process the payment. Depending on the client call, it will delegate the call to the appropriate payment type class, that is to either cash or debit card, and invoke the process payment method. And these classes, that is the cash or debit card, has logic defined in it and it knows best what to do. Now if I want to add a new payment type, say credit card, I need not to change or add any logic to the payment class. I just need to create a new class, credit card class, which need to implement the interface payment type and define its own processing payment logic. So to add the new feature, I am not touching or modifying any of the existing code. Now the application is working fine in production and 6 months down the line, you want to add one more payment type, say Google Pay. Again, I need not to change the payment class. I just need to create a new class, Google Pay, which need to implement the interface payment type and will define its own process payment logic. So the payment class and its method is closed for modification, and if we need to define a new payment type, all you need to do is to create a new payment type class and define the process payment method in it. So we are open for extension, that is to open to add new payment type, but closed for modification. That is, we don't need to change the existing payment class or any of its method to add a new feature. Hope you are able to appreciate the power of this principle with this example. We will look into some more code in the next section. For this section, let's look into a sample dummy employee salary processing application. The application is fairly simple one. Again, this is for demonstration purpose and not a full feature application. Employee salary can be categorized into two, a monthly salary and a commission-based salary. And the business rules logic of monthly salary is different from that of a commission-based salary. So let's look at the architecture of the application. We see here employee class which has attribute of salary type. That is, while creating the instance of an employee, the salary type will be set either to a commission-based or monthly salary-based, and this is a string value. Class payroll, which has the calculate salary method, refers to the employee instance and check for the salary type of the employee, and based on the salary type, it executes the appropriate salary processing logic. And there is a payroll UI, which is the UI class OCP UI. And this class is the invocation point of the application, and it calls the calculate salary method on the payroll class. As mentioned earlier, the application is fairly simple one. Again, this is for the demonstration and not a full feature application. I want to give you something to take as a base and then expand on, and want you to start thinking how you can apply the concept you are learning in your real life project. So let's dive into the code and check out action in the real world. So the two packages that you need to look at is com.ocp.base, which is the code without OCP, and com.ocp.modify, which is the refactored solution based on the open-close principle. So let's look at the files inside com.ocp.base, which is the base logic without any OCP implementation. So if I run the application, I see the output statement. So what's happening here? There's an employee class which has salary type as an attribute. There's an OCP UI. OCP UI creates the instance of the employee class with the name and salary type, as shown here, the name as Kishore and the salary type as monthly, and invokes the payroll class and calls calculate salary method. Calculate salary method is an if and else logic which checks for the salary type and invokes the appropriate salary calculation logic. Let's say this application is live, deployed, in production, and 6 months down the line there is a new requirement. There's an update to the employee contract. As a result, the application now should support one more new salary type, that is hourly salary type. With the current architecture, you need to check out for the working code and add one more if and else condition and logic to the existing production code. One more if and else statement saying that if the employee salary type is hourly, then print the hourly salary logic or invoke the hourly salary logic. So in this case, you are changing the production code and adding the additional logic, and thus there is a potential that we may break a totally unrelated part of code or introduce a new bug to the application. And this code violates the open-close principle. Typically, in a code, if you have if and else or switch statement, it violates OCP principle, because if you want to add a new case, you need to modify the if and else or the switch statement. So in this case, we need OCP principle to help so that we don't modify the existing code. At the same time, we are able to support the new salary type hourly. So how to do it? Let's see that. So this is how you will implement this with OCP. I will be creating an interface IPay classification type. This interface has one method, calculate salary. And each of the payment type, that is salary and commission class, will implement this interface and implement the method calculate salary. The payroll class will be responsible to call the calculate salary method of appropriate salary type. So if you see here, the payroll class is not holding any logic to calculate the salary. Depending on the client call, it will delegate the call to appropriate salary type class. And this has the logic defined in it, and it knows best what to do. So in the future, if there's a new requirement for a new salary type, say a hourly type, then you need not to change any existing code or logic. You can create a new hourly class which will implement the IPay classification interface, and you are all set to go. So let's dive into the code. In the real world, you will have interfaces and classes in different packages. Just for this example, we have put interfaces and classes in the same packages. And the package we are interested in is com.ocp.modify. Let's first look at the classes. Here we define our interface iPay classification with calculate salary method. Interface is nothing but a contract, and this interface is implemented by two classes, calculate salary and commission. The actual logic of how to process a monthly salary will be defined in the method calculate salary of salary class, and how to process a commission salary will be defined under the calculate salary of the commission class. So these classes know the best how to process the salary of a particular type, and these classes are of type iPay classification. The employee class salary type is of type iPay classification. So it's not a string but a type of iPay classification. In payroll, we don't have any logic defined. No if and else statement, it just invokes the calculate salary method based on the calling client code, which is the OCP UI class. OCP UI will be creating an instance of employee class, and it will have a reference to the iPay classification type. And based on the type of iPay classification, actual implementation of salary type is invoked. So in this example, the calculate salary of the commission based will be invoked. Let's run it and see. So running through the same scenario, say if there's a new requirement and a new salary type hour need to be introduced, then with this design, you need not to modify any existing production code. You just need to create a new class hourly type which will implement the iPay classification. And in the client code, if it sets employee with the payment type hourly, then the hourly calculate salary method will be invoked. So this is how OCP helps us. Now one improvement you can make to this code is not to tie yourself directly to the class. That is not having class creation in OCP UI. And that's something we'll be looking into in the last principle. Also, instead of interface, you can have an abstract class. But I've seen interface provide more flexibility. So this is how OCP helps us. As with OCP design, it doesn't modify any existing code and introduce any new bugs. Hope you have followed along. I have kept the example simple here so that you understand the OCP concept clearly, and which you can take it forward to the actual real world code. So as a programmer, this is what I want you to do. Take a look at the code in your work or personal project. Take a step back, think it through, look at the area in your application which you think has more potential to change in the future due to change in the requirement. And then think through how you can design it based on OCP principle and make it loosely coupled design, so that for any new requirement change, you are not modifying the production code. You are only modifying the production code if there is a bug, not to add new features. And OCP works in hand with SRP. As seen in SRP, here each of the class, say salary, commission or hourly, is having one responsibility and it's not doing multiple things. And each of this class will change only for one reason. Okay, so that's open-close principle. It talks about idea about open for extension but closed for modification. Hope you enjoyed it. My encouragement to you is to practice, practice and practice. The more you practice, it's better for you as you will be more comfortable with these principles. So that covers the open-closed principle. Hope by now you have got a good understanding of this principle. So quick recap of this principle. An entity should be open for extension and closed for modification. And you should extend functionality by adding new code instead of changing existing code, as we have seen in the earlier example on how to achieve this. So the only time you should be changing the existing code is to fix any bug and not to add any new feature. The right time to apply this principle in your project is during the initial design phase of the project. During initial design, you come up with the features and ideas, and you will see some of them being worth implementing in open-close principle. It's good to find open and close opportunity reactively. You deploy the system very early and the users come with a feedback and they say they want to change, and these changes are opportunity for open-close because there is a potential that this part of code could change in the future requirement or undergo modification. So that's what OCP is all about, a very powerful technique, a principle that allows programmers to build application to be more robust, more cleaner, more modular, and more future proof. And as a programmer, we feel more confident in code we write.